Before I give you some practice, let me just give you a quick reminder. When given a distance time graph, the gradient of the distance time graph represents a speed. And then when given a speed time graph, the gradient of the speed time graph represents the acceleration. Okay, same goes over here. If you look at this, the gradient of this graph represents a speed, because look, the gradient of this graph is 3, and so the speed here is 3. Well, anyway, the gradient of this graph represents the speed. The gradient of the speed time graph represents the acceleration. Same as over here. The gradient of the distance time graph represents the speed. The gradient of the speed time graph represents the acceleration. And also the area underneath this speed time graph represents the distance traveled. Okay, so the area underneath the distance time graph here represents the area underneath the speed time graph here represents the distance traveled. Well, anyway, a random graph here. Work out the speed at time equals 5. Okay, so in your mind, try to picture the 3 graphs. Which graph have I given you to play with? Well, I've given you this is the acceleration time graph, distance time graph, speed time graph, and this is a distance time graph. Which one have I given you to play with? Well, I've given you the distance time graph, so you should be thinking about this graph here in your mind. Okay. Well, anyway, what is the speed at time equals 5? So time equals 5. What is the speed right here? So press pause and have a go. Remember, well, picture the 3 graphs in your mind. I've given you this one here to play with. You know that, well, this is a distance time graph. If you want to know the speed, then the gradient of the distance time graph would represent the speed. Well, the gradient of this bit here, the gradient here is 0. So the speed at this point here is 0. And if you think about it, what's going on here is that well, what's going on is that the car, you can think of it as this. Hang on, you can think of it as this. You can think of it as a car. So this is a starting point of a car. So this is your car here. After 3 seconds, the car is 2 meters away. So after 3 seconds, the car is 2 meters away. So let's say this here is 2 meters away. And then at 4 seconds, the car is still 2 meters away. It's not moving. After 5 seconds, it's still 2 meters away. It's not moving. Here it's not moving. Here it's not moving. Here it's not moving. So well, the point is that at 5 seconds here, the car's not moving. So the speed here is 0. And then what's going on here is that after 6 seconds, then the car starts to move. 7 seconds, 8 seconds. So after 8 seconds, the car is 5 meters away. So after 8 seconds, after 8 seconds here, the car is 8 meters away. That's what's happening here. Sorry, hang on. After 8 seconds, the car is 5 meters away. Okay, so this here is 5 meters away. But the point, so what's happening is when you look at this distance time graph, after 3 seconds, the car is 2 meters away. So after 3 seconds, the car is right here. Okay, and then 4 seconds, the car is still here. 4 seconds, the car is still here. 5 seconds, the car is still here. 6 seconds, the car is still here. 7 seconds, it starts to move. 8 seconds, it's 5 meters away. 8 seconds is 5 meters away. So when I asked you what's the speed at time equals 5, which is right here, at time equals 5 here, the speed here is 0. Okay. Well, next question here. Given this random graph here, what is the distance traveled between t equals 0 and t equals 10? So 10 is right here. Okay. So press pause and have a go. Okay, the distance traveled is, well, I've given you the distance time graph here. So it's because I've given you the distance time graph and I asked you about distance, then it's just a matter of straight reading. So after 10 seconds, it's just a straight reading here. It's just 7. it has traveled 7 meters. Because what's going on here is that you can imagine this as being, you can imagine this as being like this. So a car, so this is your start here. So the car's here. So what's happening is that after 2 seconds, the car is 4 meters away. So after 2 seconds, the car is 4 meters away. Okay, and then 3 seconds, the car is still 4 meters away. 4 seconds, the car is still 4 meters away. After 5 seconds, the car, well, along here, the car's not moving. It's just staying still. And then 6 seconds, it starts to move. After 8 seconds, it is 7 meters away. So after 8 seconds, it is 7 meters away. So 7 meters away here. After 8 seconds, it's still 7 meters. After 9 seconds, it's still 7 meters. After 10 seconds, it's still 7 meters. So the distance traveled between t equals 0 and t equals 10 is just 7 meters. Because I've given you a distance time graph, and I asked you about distance. So it's just a matter of straight reading. So the distance traveled between 0 and 10 seconds is just a matter of straight reading, 7 meters. Okay, next one. So here, what is the distance traveled between t equals 0 and t equals 5? So what is it? So 5 is here. What is the distance traveled? Okay, so try and picture the 3 graphs in your mind. I've given you this one here to play with. I've given you the speed time graph, but I want to know about the distance. Okay, so I've given you this graph here, but then I want to know about the distance. So anyway, press pause and have a go. Okay, so to do this here, picture the 3 graphs in your mind. I've given you the speed time graph to play with. So so remember the area underneath the speed time graph represents a distance traveled. So if you want to know, if when given the speed time graph and you want to know about the distance, you have to find the area underneath the graph. So in this case, it would be this area. So it's you trying to find this area here. So I would split this up like this. So find the area of this. Well, the area of this would be the up and down times the across here. The up and down here is 2, and then times the across here. The across here is 3. So it's the height times the base here, which will be 6, and then because it's a triangle here, you've got to divide it by 2. So that would be 3. So this area here is 3. Okay, and then t equals 5. So now the area here would be the up and down here is 2 times the across here, which is also 2. So this here is 4. Okay, so this here is 3, and this here is 4. So the area here is 7. So the distance traveled is 7 meters. Okay.